You know, in this world we've built, this world of steel and concrete, there's an enemy we can't see. It's a hidden flaw, a microscopic crack, a stress point just building in silence. The bridges we cross, the planes we fly in, the buildings we live in, all of it relies on the integrity of metal. And that integrity, it's under a constant, invisible threat. So what if that single point of failure is smaller than a human hair? A mistake that no one, and I mean no one, could ever see with their own eyes, just waiting for the right moment to cause absolute catastrophe. This isn't some sci-fi movie plot. It's a daily reality in the world of advanced manufacturing. At the end of the day, it all comes down to metal fabrication. It's the art of turning raw metal into these incredibly precise components that, literally, hold our world together. But here's the catch. With every new, more complex design, the risk of these invisible flaws just gets bigger and bigger. And the stakes here are, well, they're massive. We're not talking about some small niche industry. The global metal fabrication market is projected to be worth almost $28 billion by 2032. That is a colossal industry, built on a promise of perfection, where anything less just isn't an option. Okay, so let's get into this. For decades, our first and last line of defense has been the human eye. Right? You've got skilled inspectors looking for any little sign of a problem. But in today's world, with the demands we're facing, that traditional method is, well, it's reaching its breaking point.
I mean, just think about it. An inspector, no matter how skilled they are, gets tired. Their attention can wander. The process takes hours, which is just not efficient when you're cranking out thousands of parts. And when you're dealing with these incredibly complex components for, say, aerospace or the auto industry, some defects are just too small or too subtle for our eyes to catch. We're simply outmatched. And that reality has led researchers to a really powerful conclusion. We are way past the stage where automation is just a nice-to-have. To guarantee safety and quality at the scale modern manufacturing demands, it is an absolute necessity, essential.
So how do you fight an enemy you can't see? You build an all-seeing eye. This is where we get to see the rise of machine vision, a technology that doesn't just copy human sight, it blows right past it.
At its core, machine vision is actually pretty simple. It uses super high-resolution cameras to see and incredibly powerful software to think. It's like having a digital inspector that never blinks, never gets tired, and can see details far beyond anything we could ever hope to.
So here's how it works. First, a high-quality camera snaps a super detailed picture of a part, right there on the production line. Second, that image gets fed instantly to an AI that's been trained on thousands, maybe millions of examples of what's perfect and what isn't. And finally, in a fraction of a second, the AI makes a call. It identifies, classifies, and flags any defect, from a tiny scratch to a component that's just a hair out of place.
And the power of this? It's just staggering. This isn't a small improvement. With these AI-driven techniques, like something called semi-supervised learning, these systems can hit accuracy rates of up to 99.69%. I mean, think about that. That level of precision gets us right to the edge of the holy grail, zero-defect manufacturing.
Okay, but what about the flaws that haven't even formed yet? You know, the hidden stress and strain building up deep inside the material itself? For that, we need a totally different kind of sight, a way to read the invisible language of metal when it's under pressure. And this is where a technology called digital image correlation comes in. Digital image correlation, or DIC for short, is this really cool optical technique that basically watches a material deform in real time. It's not looking for cracks that are already there. It's looking for that microscopic stretching and pulling that happens right before a crack even begins to form. So how on earth does it do that? Well, the key is to give the metal a unique fingerprint. To track movement, you've got to have something to track. And that's where a speckle pattern comes in. It's just a random, high-contrast pattern that gets applied right to the surface of the material. And this fingerprint can come from the material's own natural texture, or it can be created artificially. Usually it's a fine mist of black and white paint, or if you need ultimate precision, a pattern can be generated by a computer and printed right onto the component. Every single tiny speckle becomes a unique point to track. And this is where the magic happens. As the part is put under some kind of force, a camera watches that speckle pattern. A computer tracks the movement of thousands of these little points, creating a full map of the strain across the entire surface. This reveals the hidden stress points, the exact spots where a failure is most likely to start. It's predictive power on a microscopic level. It's amazing. So, when you combine the all-seeing eye of machine vision with the predictive power of digital image correlation, you don't just get a better inspection process. No, you get an entirely new way of thinking about quality, safety, and manufacturing itself. A whole new paradigm.
And this isn't some one-size-fits-all solution. The real power here is in the synergy. Different manufacturing processes, like the high-pressure cold rolling or the super-hot hot rolling of steel, they all create unique challenges. So engineers pair the right tool for the job, matching specialized cameras with different kinds of AI algorithms, each one trained to spot the unique defects for that specific process. It's like a customized web of automated quality control.
Now look, the road ahead isn't without its bumps. The initial setup costs can be really high, the algorithms are incredibly complex, and these systems have to be perfectly tuned to avoid mistakes. But the promise? Wow, the promise is undeniable. A future of zero-defect manufacturing, predictive quality control, and a level of safety and reliability in the things we build that was just unimaginable before.
Which leaves us with one final thought. We are quickly moving into an era where our most critical infrastructure isn't just built by machines, it's guaranteed by them. So as we hand over the job of inspection to these tireless, all-seeing systems, we have to ask ourselves, what does it really mean for our world when perfection becomes the only acceptable standard?